Today in this video we are going to learn how to integrate using partial fraction decomposition. Partial fraction decomposition is the process of breaking down complicated rational fractions into simpler fractions which are easier to integrate. We're going to be using the Heaviside method in our solutions. The Heaviside method is extremely useful when trying to compute the coefficients of rational functions when we are integrating using partial fraction decomposition.
This is our first problem. Find the integral of x plus 1 over x squared minus 4 dx. So we notice that x squared minus 4 can be factored into two factors, x minus 2 and x plus 2. So we can set this equal to times x plus 2 dx. So now this is where we're going to use partial fractions to find the integral of this rational function. Okay, so we're going to set this equal to a over x minus 2 plus b over x plus 2 will be equal to x plus 1 times x squared minus 4. We don't know the values of a and b yet, but what we're going to do next is to find out the values of those two variables. So we're going to take this whole expression and multiply it by x squared minus 4. So on the right side, that's just going to cancel out with the denominator. So we'll just have equals to x plus 1 on the side. And then on the left side, when we multiply a over x minus 2 times x squared minus 4, the x minus 2 factors are going to cancel out. So we'll just have a times x plus 2. And then when we multiply b over x plus 2 times x squared minus 4, the x plus 2 factors are going to cancel out. So we're just going to have b times x minus 2. Okay, so this is where we're going to finally use the Heaviside method. We're going to let x equal to negative 2. So this would basically make the whole a term be equal to 0. So we can now solve for b. When we plug in negative 2 for x, we're going to have negative 2 minus 2 times b, which is just negative 4b, is equal to negative 2 plus 1, so negative 1. So we'll have negative 4b is equal to negative 1. So b is equal to 1 over 4. Similarly, to solve for a, we're going to have x is equal to 2. Now the b term will be equal to 0. We can disregard it. And then 2 plus 2 is 4. So 4 times a is just 4a is equal to 2 plus 1, 3. a is equal to 3 over 4. So the integral of a over x minus 2 plus b over x plus 2 dx is equal to the integral of 3 over 4 times 1 over x minus 2 plus 1 over 4 times 1 over x plus 2 dx. This is what we get when we substitute the values for a and b. Now we can easily find the integral of this because we know that when there is the first power of x in the denominator, the antiderivative is just the natural logarithm. So now we have 3 over 4 times the integral of x minus 2 plus 1 over 4 times the integral of 1 over x plus 2 dx. And this will all be equal to 3 over 4, the natural logarithm of the absolute value of x minus 2 plus 1 over 4 times the natural logarithm of the absolute value of x plus 2 plus c. And that is our answer. Now let's try another problem. Let's find the integral of 5 over x squared plus 4x plus 3. Pause it here to solve for yourself. Okay, Again, like the previous problem, the denominator in this problem can be factored into two factors, x plus 3 times x plus 1, and the numerator will just be 5, and this is what we'll have. So when we perform partial fraction decomposition on this, we'll just have a over x plus 3 plus b over x plus 1 is equal to 5 over x squared plus 4x plus 3. Okay, so now to solve for a and b, we're just going to do the process that we did last time. We're going to multiply this whole thing by x squared plus 4x plus 3. Again, like last time, this is going to cancel out with this. And we're just going to have 5 on this side. And then on the left side, the x plus 3 will cancel out with the x plus 3 factor of that. And we're going to have 8 times x plus 1. And then the x plus 1 and the x plus 1 are going to cancel out. And then we'll just have b times x plus 3. So this is what we have so far. And then now we're going to have x equals negative 1. And then we're also going to let x equal negative 3 for the next one. But let's solve x equals negative 1. So this will be equal to 0. And then negative 1 plus 3 is 2. So 2b will be equal to 5. And then b is just equal to 5 over 2. Or if you prefer, 2.5. And when x is equal to negative 3, this will just simply be 0. And then negative 3 plus 1 is negative 2. So negative 2a is equal to 5. And then a is equal to negative 5 over 2. Or negative 2.5, if that's what you prefer. Now we can plug this back in. So we had the integral of a over x plus 3 plus b over x plus 1 is equal to 5 over 2, negative 5 over 2, times x plus 3 plus 5 by 2 times x plus 1 dx. Now we're just gonna do the same thing again. The antiderivative of the first power of x when it's in the denominator is just natural logarithm. So we're gonna remove the coefficients, and then we're gonna have plus 5 by 2 times the integral of 1 over x plus 1 dx, which will just be negative 5 by 2 times the natural logarithm of x plus 3 plus 5 by 2 natural logarithm of x plus 1 plus the absolute value of x plus 1 plus c. So that is our answer. Let's do one last question. So we're going to find the integral of 7 minus x squared over 5x cubed plus x dx. So this would be equal to the integral of 7 minus x squared over x times 5x squared plus 1, because we can factor out the x in the denominator. So if we put it in the form that we've been using so far, we would have a over x plus b over 5x squared plus 1 is equal to 7 minus x over 5x cubed plus x. So now we're going to multiply this whole expression by 5x cubed plus x. Just a standard procedure. Now again, this is going to cancel out with the denominator. We're going to have 7 minus x on this side. And then on the left side, we're going to multiply it with the a over x. And we're going to get a times 5x squared plus 1, and then plus b times, and then this is going to cancel out with the 5x squared plus 1 and just leave x, and we're going to get b times x. So now we're going to use the heaviside method. We're going to let x equal 0. So this will just be 0. And then when we plug in 0 for x over here, then we're going to have a times 1 is just equal to 7 minus 0. So a is just simply equal to 7. Now, since we can't have this expression be equal to 0 in any way, we're going to have to try a different approach. Now that we know that a is equal to 7, we can plug in any value of x. Let's say x equals 2. Then we're going to have 8 times, let's plug in 2 for x right here. We're going to have 20 plus 1, so 21, plus b times 2. So we're just going to have, that's just going to be 2b is equal to 7 minus 2. When we plug in 7 for a and use the calculator, we get b equals negative 71. So that will be our answer for b. Now let's scroll up to see what our form was. Okay, so it will be 7 over x plus negative 71 over 5x squared plus 1. So now we just find the integral of this. Okay, so now we can split this up into two integrals, like so. 7 times the integral of 1 over x dx plus negative 71, the integral of 1 over 5x squared plus 1 dx. So we know that this integral over here will just be 7 natural logarithm of the absolute value of x, and then minus 71 times. However, this expression cannot be the natural logarithm of 5x squared plus 1 because the derivative of 5x squared plus 1 is not in the numerator. So it's actually going to be an arctangent. So we're going to have arctangent 5x over 1 square root of 5x over 1. And then we're going to divide by square root of 5x over here to account for the u substitution. If you don't know the antiderivative of this, then I highly suggest you review your antiderivative of derivative of arctangent, arcsecant, and arcsine.